Welcome back to my channel. In today's video, I'll be discussing about the graph of the function y equals to x cube. In the previous videos, I have discussed about the graphs of y equals to x and y equals to x square. So both of those two graphs are well-known graphs, as one is a straight line and another one is a parabola. However, the graph of y equals to x cube is not a well-known graph. Now we start by analyzing its properties at first, and by using those properties I will draw the graph of that function. So first is y equals to y at 0 gives 0. So here we have the function yx equals to x cube. So if we put 0 here, we will get a 0 here too. So this graph must pass through the point 0, 0. Okay. Next is, if x is greater than 0, then y is greater than 0, and if x is less than 0, then y is less than 0. Why is it? Because as x is greater than 0, we also have x cube greater than 0, and similarly if x is less than 0, so we must have x cube less than 0. So this gives y greater than 0 and this gives y less than 0. So this first case we have the positive means x is also positive and y is also positive, and in this second case we have negative. So here we have x is negative and y is also negative, and this positive occurs at the first quadrant, and this negative occurs at the third quadrant. So this graph must be in the first and the third quadrant, here and here. Okay, for the increasing part, so for the next part we can analyze its increasing or decreasing property. So first we have done the derivative of that function. So derivative of x cube is obviously 3x square, and this x square, this term is always greater or equals to 0, and as the derivative is always greater or equals to 0, the function must be increasing. So as the x increases, y must also increase. Okay, next we have this. So we need to check whether the function has a maxima or a minima. For that we can do the derivative. So derivative equals to 3x square. The derivative is 3x square, and if we equate it to 0, we get this x equals to 0. Now if we do the double derivative, so x equals to 0, this x equals to 0 is a critical point. Critical point. Next, we do the double derivative, and here an amazing thing is that the double derivative is also 0. So we cannot say that this function is this x equals to 0 is a maxima or a minima. And also if we do the third derivative, so there is a theory, if we do the third derivative here, dx3, that will give us 6. This is not equals to 0. So this x equals to 0 is neither a maxima nor a minima. Moreover, in this case we can say that this x equals to 0 is a point of inflection. So what is a point of inflection? In case of point of inflection, if the function changes its concavity, so it may become, for the point of inflection, the function may become concave to convex, or it may become convex to concave. So this is the point of inflection where the function alters its concavity. Next, so we can check out the concavity of the function y equals to x cube. So for that, we do the double derivative, and for the double derivative we have 6x. So from here we can say that this 6x will be greater or equals to 0 if x is greater or equals to 0, and this is, or moreover we can omit the greater or equals to part. So for that we have this, and less than 0 if x less than 0. So for x greater than 0, the double derivative is greater than 0. That means the function is convex. So here, if we consider this positive direction, positive x-axis, here the function must be convex, meaning it must have this kind of shape. And for this part, the negative x-axis part, this part here, the function is concave. So for concave, it must have this kind of structure. Okay, and moreover, why I haven't drawn it like this or this, like a flat kind of thing, because I know that the function is increasing from this point 4. Okay, so we have this kind of structure, and this structure is, if we join this structure is satisfying each and every property. So from the second property we can see that this structure, if we join it here, join this part, then this function will pass through, 0 0. Again, it lies in the first quadrant and third quadrant. Again, for the fourth part we have this always increasing. The fifth part, it has a point of inflection, it satisfies the sixth part. And also this case, at y equals to 1, the function has the value 1. So we have two values here from which we can draw the function 1 1 and minus 1 minus 1. And also if we check the limit at infinity, so for limit at infinity we have this function, this one here, as infinity, because if x is in positive, it is the positive direction of x-axis, so the limit must give the positive infinity. And in this case, if we consider the negative infinity, we have this negative infinity. So from the function, from the graph of this function here, we can say that as x increases, the graph is increasing towards infinity along the y-axis, positive infinity, and as the x decreases, here we can see that the graph of this function decreases toward the negative infinity. So if we do the fair version of this graph, we get this graph which satisfies each of those properties. So let me again check all these properties. First is the second property, which is this 0 0 property. So it satisfies the 0 0 property here. Next is this first quadrant and third quadrant property and increasing property. So it also, this function, it lies in the first quadrant and third quadrant, and also the function is always increasing. Next, it has a point of inflection where the concavity changes for concave to convex. And also this function passes through the point 1 1 and minus 1 minus 1, and also as the x goes towards infinity, the function goes toward positive infinity, and as the x goes toward the negative infinity, the function goes toward the negative infinity. Now the domain and range, we can see that this function spans around the whole y-axis. So obviously it can have any value as input, and also from the graph itself we can see that it can have any value as an input and it will get any value as an output. So see, the range and domain of this function is real axis. And also as similarly as the x function and x square function, this function here is again a polynomial function, moreover an algebraic function. Next is odd function. So for the odd function, we must have f of minus x equals to minus fx. So here it satisfies this. F of minus x means minus x cube. It will give minus x equals to minus x cube. So it is minus fx. So f of minus x equals to minus fx. So it is an odd function and it must be symmetric about the opposite quadrant, which is the case, the opposite quadrant, which is the first quadrant and the third quadrant. Next, it is an increasing function. So we have proved it. And next, it has a point of inflection at x equals to 0. And lastly, it is continuous and differentiable on R. So for continuity, we can see that we can continuously draw the graph of this function. And as this graph has no sharp edges, it must be the smooth function or a differentiable function. So again, I can do the thing. So for continuity, we have fx equals to x cube. Take any arbitrary point a. So limit x tends to a fx. So this is the x cube. X cube will give limit x tends to a x cube a cube. It is f of a. So the function is continuous on R. So it must be continuous on the whole real axis. Next, for the differentiability, we have this one here. Limit x tends to a fx minus fa divided by x minus a. And here we have limit x tends to a. So x cube minus a cube. So we can factorize that x cube minus a cube. So we have limit x tends to a x minus a. So if we do the factorization, we have x minus a x square ax plus a square divided by x minus a. So x minus a will get cancelled out from the numerator and denominator, and by putting the value a here, we have putting the limit x tends to a, we have 3a square. So the limit exists and the function is differentiable at a, and as a is an arbitrary real number, the function is differentiable in the whole real axis. So I have discussed about both these functions y equals to x square and y equals to x cube. Now we can generalize these two functions as y equals to x power 2n and y equals to x power 2n minus 1, which are the even integer power and odd integer power. So for those two functions, the properties will be somewhat similar to x square and x cube, but we will see in the next video how the values or how the certain values changes as the n changes, which is the power 2n, which comes from the power 2n and 2n minus 1. Thank you for watching this video. Please like, comment and subscribe to this video and share this video with others who are preparing for the different exams. Thank you.